So rule number 5, that's just defining placeholders. So yesterday, remember we said if it's not significant, it's a placeholder. And so the purpose of a placeholder is just to show the size or the value of the number. We did, like you had something like this, 6500 grams. Those zeros are placeholders. If you go through the rules, are those zeros trapped between two non-zeros? No. Is there a decimal point? According to rule number 3, right? Is there a decimal point? No. Are those zeros underlined? No. So all it is saying is then these two zeros are placeholders. And these two are significant. The 5 would be the guess. The 6 we're sure about. So we'd have 2 sig figs. So that would be, just reviewing rule number 5. Rule 6 is these rules are used for measurements only, not counting numbers or exact conversions. So these rules are used for measurements only, not counting numbers or exact conversions. So when we measured the width of the table, we got out the meter stick. And you measured it to be 6 decimeters, and then you made a guess, right? 6.1 decimeters, 6.2 decimeters. So anytime, Rachel, you are measuring, you have significant figures. But if you are not measuring, you don't have sig figs, okay? So when are you not measuring? When you are counting. So if I asked you, Brenna, how many students are in this class, you would literally count them, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 students. I'm going to include myself just for the heck of it. So 21 students, because I'm a learner too. Is there any guess about this? Is the 1 a guess? No. We know for certain there are 21 people in the room. So there is no guess. We know exactly there are 21 people. So more correctly, we would say it's 21.0000 out to infinity. And we would say the number 21 has an infinite number of sig figs. That's technically the correct way to look at a counting number. It's 21 exact, 0.000 out to infinity. And therefore to have infinite number of sig figs. And the same thing works with things that are exact conversions is what I like to call them, or by definition. If I say 100 centimeters are in 1 meter, why are there 100 centimeters in a meter? Because a bunch of French guys got together and said, hey, let's make it 100. Okay? So it was by definition. They chose that. And it's not 100. Technically speaking, it's 100.0000 is equal to 1.0000. And so, just like with the 21 students, this has an infinite number of sig figs. And this has an infinite number of sig figs. anytime you go from metric to metric, they each have infinite. Anytime you go from English to English, it has an infinite number. So 1 foot has 12 inches. Each of these has an infinite number of sig figs because it's exactly 1 and it's exactly 12. So it's really 1.00000 and 12.0000 out to infinity. And it will take a little bit of practice trying to figure out, counting numbers versus measurements. So any questions on rule number 6? And there should actually be another rule on here. For numbers greater than 1, if there is a decimal point then all digits are significant. So for numbers greater than 1, if there is a decimal point, then all digits are significant. So let me show you examples of that one. So suppose you have this number, 500.0 grams. Is 500 greater than 1?
Yes.
Yes. Is there a decimal point? Yes. So then all the digits are significant. The last significant digit is your guess. So that one's the guess, and these we're sure about. So that would give us a total of 4 sig figs. Let's contrast that with this one. Now let's stick with the number 5. Let's make it the same. And anytime you get a number, Brett, you just work yourself through the rules. So, are those zeros trapped between non-zeros? No. So rule 2 doesn't apply. Rule 3, is there a decimal point? No. Okay, so rule 3 doesn't apply. Rule 4, are one of the zeros underlined? No. Rule 5, that will probably apply. Rule 6, this is not a counting number. Rule 7, is there a decimal point?
No.
No. So basically this is rule 5. These 2 zeros are placeholders. And all non-zeros, Alex, are significant. That's rule 1. All non-zeros are significant. So the only sig fig is the 5, and the last sig fig is always the guess. So in this case, that's our guess. Yep, Jared.
So, like, basically, it's just a complete guess.
What?
It's basically just a complete guess.
This number is a guess.
Like the
Yeah.
And what's the point in providing it?
Well, you're still making a guess, better than nothing. You do have to get more accurate, go out and get a better machine so you get more accuracy, but we would say it's an educated guess. Not just a random guess. Okay, so now I'm gonna